Today we'll be looking at the topic of particle dynamics. Here's a sample question. A block of metal with mass 2 kilograms on a horizontal table is attached to a mass of 0.45 kg by a light string passed over a frictionless pulley at the edge of a table. The block is subjected to a horizontal force by allowing the 0.45 kilogram mass to fall. The coefficient of sliding friction between the two blocks and the table is 0.2. You want to calculate the initial acceleration. So first, we look at the small m. The small m has gravity acting on it of mg and the tension of T. So for a small m, the net force will be mg minus T. Set F net equals to ma, and you get equation of ma equals to mg minus T. Now we'll look at big M. So big M, the mg and the normal force cancels out. So we'll look at the horizontal part. Horizontal part has a tension force this way. There's also a friction force this way. So for big M, the friction force will be big M times mu and g. Now we get F net equals to tension minus big M mu g. Set F net equals to big M and A. Now we get M A equals to T minus mu M mu g. Now we get the equation 2 and equation 1. We add them together, we get MA plus MA equals to mg minus T plus T minus m mu g. Now we get A equals to small m plus big M equals to mg minus big M mu g. Divide both sides by m plus big M, you get A equals to mg minus m mu g over m plus m. Sub in the values, and you get equals to small m 0.45 kilograms times 9.81 minus 2 times the coefficient of friction is 0.2 times 9.81 over 2 plus 0.45, so 2.45. And when you plug it into a calculator, you should get around 0.2. So for part B, we have to calculate the tension in the string. So you're going to look at the equation 1 from part A. We can rearrange for T. So T equals to mg minus ma. Now we factor out the m, so T equals to mg minus a. Then we plug in the values of m is equal to 0.45 times 9.81 minus the gravity was acceleration was 0.2. And then we plug it in, and you get around 4.32 newtons. So for part C, we're going to find the distance the block will continue to move. After 2 seconds of motion, the string should break. So after 2 seconds, we find the initial velocity of the block. So v1 equals to v0 plus at. Plug it in. v0 is 0. So v1 equals to 0.2 times 2 seconds, which is equal to 0.4 meters per second. Now, the only force acting on the block if the string breaks will be the friction force. So let's draw the block right here. The friction force disappears, and the only force will be the friction force. You can calculate the friction force by finding the rule ma equals to m mu g. After you cancel out the m, you get a equals to negative mu g. Now we can use this to calculate the distance by the formula v2 squared equals to v1 squared plus 2ad. Rearranging this for distance will give you d is equal to v2 squared minus v1 squared over 2a. Now we know v2 will be 0 because the mass will stop moving. So equals to 0 minus v1, so 0.4 squared over 2 times mu g. Substitute it in, equals to negative 0.2 times 9.81, which is equal to approximately 1.96 meters per second squared. So substitute this in, negative 1.96 meters per second squared equals to around 0.0408 meters.